Good afternoon. Thank you for joining my session. My name is Arek Borucki. I work as machine learning platform and database engineer at Hugging Face. I have a question to you. Who knows Hugging Face? Nice. And who use Hugging Face? Perfect. Today, I would like to walk you through how Hugging Face scaled with MongoDB Atlas and how we ended up serving almost 3 million models to developers around the world. I'm going to share architecture decisions we made, challenges we faced, and lessons we learned while scaling MongoDB Atlas to support one of the largest growing AI communities in the world. I have also some live demo for you. I will show you what the Hugging Face Hub is, and I will tell you about MongoDB use cases at Hugging Face. I hope you will like this session. Let's get started. Before we dive into technical details, let's talk about scale. Currently, Hugging Face has more than 13 million users, and this number is growing really fast. We serve more than 2 million public models, actually almost 3 million, and I will show you this during live demo. We have much more than 500,000 datasets, more than 50,000 organizations are using Hugging Face. And I'm not talking only about hobbyists or researchers. More than 30% of Fortune 500 use Hugging Face in their AI workflows. Just to put this growth into perspective, 2 years ago, we had 20,000 models. Now we have almost 3 million. MongoDB is our main database. Almost all use cases at Hugging Face are using MongoDB. Currently, we are using Replica set, but we are going to shard our collections and use sharded clusters to be prepared for more users, more data, more throughput, and more growth. I want to show you some short video about public models on Hugging Face Hub. Last 2 years are amazing for us, and please note that this slide stopped in 2025. Now we have 2026, which means we are serving much more models. Okay, let's talk about high-level overview now. When user interact with Hugging Face Hub, his request flows to Hub frontend, then to Hub API, and then to MongoDB Atlas. MongoDB Atlas is source of truth for our metadata. And there is one important point that sometimes surprises people. We are not keeping models in MongoDB. We keep everything about the models. what doesn't mean in practice. We store in MongoDB metadata, user information, repo information, and so on. Models physically, model artifacts physically are NS-free. And MongoDB only keep pointer to the model in MongoDB documents. Also, we index our model cards, dataset cards, and some Python application files, and we store them in Atlas search. This is what powers our efficient full-text search on the Hugging Face Hub. Now let's switch to my laptop, because I want to show you Hugging Face Hub in practice. So now I'm going to do some live demo and introduction to Hugging Face Hub. We have 4 pillars currently on Hugging Face: models, datasets, spaces, buckets, which are new feature, and we will talk about this soon. And if someone wants to learn more, we have very good documentation which describes everything in details. You can also use Hugging Face chat to ask questions about this documentation. But now let's come back to models. You can search models by using plenty of attributes. For example, I want to get text generation. And I see, or any to any, and I see how fast is it. In reality, I'm searching now in MongoDB Atlas, because metadata is in MongoDB Atlas. For example, if I want to use less parameters, like a couple of billions less, and still I can see right models. For example, I want to know which model is using transformers, and I have almost real-time results. Also, I can use full-text search here to search any information via Atlas search. For example, text to audio. And I'm able to go to Hugging Face Hub and fetch this model pretty fast. So this full-text search is using MongoDB Atlas under the hood. Or for example, if I want to search something about MongoDB and embedding. So now I'm redirected to MongoDB organization in Hugging Face Hub. I can see model card, and here I have always description. So this model is good, for example, for RAG use cases. I can deploy this model. I can use Hugging Face interface providers or any major cloud provider, and I can also use this model directly via Hugging Face transformers. So here I have simple copy-paste to my code, and I will be able to use this model without bigger issues. Let's come back to the hub. We have also datasets. So that's the place. Actually, I forgot to show you that we have almost 3 million models. So, and this number is changing very fast. I'm sure in a couple of weeks there will be 3 million and something datasets. We have almost a million datasets now. And again, I can use very fast search in MongoDB to filter models I need. If I go again to full text search, and I put MongoDB embedding, I will see dataset. And here, I have ready-to-use embedding. I'm using those datasets for learning purposes. So for example, when I was learning Atlas vector search, I was using MongoDB embeddings from Hugging Face, simply because I didn't want to generate embeddings by myself. It was the easiest part. It was just to download dataset from Hugging Face and upload this to MongoDB. We have also spaces. So that's the place for AI applications. Everyone can publish space in this place. I want to show you something new. Our machine learning inter. Actually, I was setting MongoDB cluster for this chatbot 2 weeks ago, which means MongoDB doesn't power only Hugging Face Hub. It's power plenty of other use cases. And here, for example, I can ask, who are you? So it means this chatbot can help me to navigate via Hugging Face, search models. Also, I think you can use this chatbot to tune your own models. The last pillar of Hugging Face Hub is bucket. That's a new feature. It's maybe 2 months old. And guess which database is powering Hugging Face storage bucket? It's obviously MongoDB Atlas, brand new cluster. The idea is that AI agents or AI teams can use those buckets as they are cheaper than classical S3 stuff. They use Hugging Face CDN and XSET deduplication technology. And here I have examples how to use those buckets. Maybe let's switch to console. I can also interact with Hub via Hugging Face CLI. So I'm already authenticated. And for example, I want to create a bucket. So I can use CLI Hugging Face bucket create. Let's put MongoDB.local. So my bucket has been created. Let's try to, yeah, it's right over there. And if I go to my Hugging Face account, I should see my bucket. Yeah, it's there. And I can store my models in this bucket, and I can use my agent to interact with this bucket, because agents need some data layer for interaction. Okay, let's switch to slides now, please. Now let's talk about infrastructure which power all of this. Currently, we are using MongoDB 7-node replica set cluster. At daily basic, we have around 40K reads per second, but this number is also changing. I saw lately spikes to 140K because our throughput is now increasing, and we need to be obviously prepared for this. We are using 7-node replica set member. 3 of them are electable. It means each of them can become primary. 3 of them are read-only nodes, so we can isolate some heavy queries from electable nodes. To do this, you just put in connection string next to driver tag, which will be saying read-only, and then your query will be routed to read-only node. We also use one analytics node for some ad hoc queries, some analytical dashboards, and so on. So we are trying to not mix our analytical traffic with production electable nodes. We are trying also to use read preference, secondary preferred, to offload primary. So we are running on primary queries which really need strong consistency. Anything which doesn't need doesn't have to use the latest data goes to secondaries. We also use nearest sometimes. It means your query can go to primary and to secondaries. This is case by case, actually. So when you do tuning, you just examine your queries, and you need to make decision if this query can go on primary, or maybe this query should go on primary or on secondary, or maybe this query must go to secondary. We are trying to use fast disks, SSD, but also we have some clusters which are using local NVMe disks. I'm a big fan of local NVMEs because I know from experience that database is faster if database have very fast and efficient disk, obviously. What is also useful in Atlas, autoscaling. Atlas is able to scale disk. For example, if your disk will get like 80 or 85%, will be 80 or 85% full, Atlas is able to automatically scale your storage, but also Atlas is able to scale your cluster to biggest tier. I saw on production that sometimes it's useful, especially when we are getting some spikes which are taking a couple of hours or maybe a couple of days. So that's current architecture. This diagram shows 7-node replica set. As I told you, we are using primary, obviously for writes, and sometimes for reads, but we are trying to distribute this traffic across as many replica set members as we can have. This analytic node is hidden node, and if there is really something which is some aggregation or some very complex query, I'm trying to use this hidden node for this kind of workloads, just to making sure that those queries are separated from other traffic. What we run on secondaries? So as I told you, we are trying to keep our primary mostly for writes. And if we have any complex aggregations, they go to secondaries, but also change streams. We are running change streams mostly on secondaries because we have plenty of pods, like thousands of pods. Plenty of them are using change streams, and sometimes when I restart those pods, they are trying to connect at the same time to find his place in chain stream, etc. So I decided just to move this workload to secondaries. They are distributed across, I think now, 5 members, which makes our life easier. And ad hoc, everything what is ad hoc. For example, sometimes people are trying to query that doesn't use index, so I recommend them just to connect directly to hidden node and run those kind of traffic there. Another important thing which we have at Hugging Face is data modeling. MongoDB flexible schema doesn't mean no schema. You need to spend some time and do proper data modeling. For example, 2 weeks ago, we started to use MongoDB compute pattern. So basically, we are pre-computing some data, and queries from applications are using those pre-compute values instead of running heavy traffic on our production database. We prefer also to use embeddings. We use embeddings when we can, but again, you need to remember to not embed too many things, because then you will hit 16 megabytes limit, and you should not even get close to this limit. So we should put to document only information which is really needed, and then MongoDB works very fast because one query will take everything what you need to your application. Another important point are indexes. We are obviously using compound indexes, but not only compound indexes, also multi-key indexes. And we are trying to make sure that those indexes are really used. What I'm doing, every 24 hours, I'm downloading logs from Atlas, and I'm running logs analyzers, for example, keyhole. And I'm able to see which query is not using indexes in correct way, or which query is not using indexes at all. And I'm able to fix this before we will get into some problems. Also, I monitor index usage, because indexes, obviously, they consume space, and we shouldn't have more indexes than really we need. Sometimes, as I saw in other companies also in the past, that database had indexes, but queries doesn't use this, so I'm trying to drop such indexes. Actually, first I use MongoDB feature, which let me hide. You can hide indexes, which means query optimizer will not see them. And then, if I don't see any bigger problems, I'm dropping them after 2 or 3 weeks. And Atlas search is a big thing for us. Now, full text search is available in Atlas, but not only in Atlas. Also, I saw that MongoDB Community Edition is supporting search, which means there is separate MongoT process, which is wrapped around Apache Lucene, and you can use efficient full-text search also on-prem. We are not using this on-prem, obviously. We are using Atlas, and we are happy with this. Plus, we started to use vector search, which is not on production yet, but I think we are going to use vector search on production as well. And this is where we go. Sharding. Currently, we are running Replica set. And this is a simple setup. You have one primary, you have 6 secondaries, but we are growing fast. We are getting plenty of new users. Our databases are growing, throughput is increasing. And we decided to start using sharding. In Atlas, as you can see, sharded cluster has more components than Replica set. So you have config servers, you have MongoDB routers, you have balancer, etc. Fortunately, in Atlas, it's easy to run sharded clusters because Atlas automates this. I remember time when I had to run this on-prem, and yeah, it was possible, but it wasn't as easy as it is now with Atlas. The only hard part is to choose shard key. And this is most important decision which you need to take when you are starting to use sharded clusters. Fortunately now, you can use shard key analyzers. This is what I'm actually working on now. So I'm using MongoDB sampling, which means I'm collecting queries from production to collection in MongoDB. I'm not using profiling because I'm afraid that it will be too heavy for our clusters. That's why I'm using sampler, which is not affecting performance that much. And then I will use shard key analyzer to analyze my ideas of shard key. And then I found this way of choosing shard key much more easier than just guessing. We have also something called Hugging Chat. This is another application which is using MongoDB at Hugging Face. This is chatbot like Claude or ChatGPT, but you can choose your own open source model, which will be using this chatbot. And MongoDB is main database where we store all metadata, all settings, and also conversations. So this is only also Atlas. I have some demo, but I think we don't have time for this demo because I have only 1 minute which left. So I will not play this demo because I want to tell you about Mongoku. Mongoku is open-sourced web graphical user interface for MongoDB. We are using this at Hugging Face. You can check this on our GitHub. You can run this in your web browser. You can share queries on Slack with your developers, just posting link to Mongoku. We found this very useful, and we are using this in our internal teams. So if you are interested, feel free to just download Mongoku and check it out. Thank you very much. It was a pleasure to be here. I hope my session was nice, and I hope you are satisfied. Thank you.